Welcome. Let's continue doing projectile motion problems. And this, I think, this video will be especially entertaining because I will teach you a game that you can play with a friend. And it's called, Let's See How Fast and How High I Can Throw This Ball. And you'd be surprised. It's actually quite a stimulating game. So let me just write down kind of let me write down everything we've learned so far. Change in distance. Oh, that might be too. Let me stay with the blue. I never used the blue. Change in distance is equal to average velocity times time. And we know that change in velocity is equal to acceleration times time. We also know that average velocity is equal to the final velocity plus the initial velocity over 2. We know the change in velocity, of course, is equal to the final velocity minus the initial velocity. This should hopefully be intuitive to you, right? It's just how fast you're going at the end minus how fast you're going at the beginning. Divided, no division. It's just, I got stuck in a pattern. It's just VF minus VI, of course. VF minus VI. And then, these might, you probably already knew this before you even stumbled upon my videos. But, and the two non-intuitive ones that we've learned, and they're really just derived from what I've just written up here. If you ever forget them, you should try to derive them. And actually, you should try to derive them even if you don't forget them, so that when you do forget it, you can derive it. But it's change in distance, let me change it to lowercase d just to confuse you. Change in distance is equal to the initial velocity times time plus at squared over 2. That's one of what I'll call the non-intuitive formulas. And the other one is that the final velocity squared is equal to the initial velocity squared plus 2ad. And we've derived all of these, and I encourage you to try to rederive them. But using these two formulas, you can play my fun game, how fast and how high did I throw this ball? And all you need is your arm, a ball, a stopwatch, and maybe some friends to watch you throw the ball. So how do we play this game? We take a ball and we throw it as high as we can, and we see how long does the ball stay in the air. So what do we know? We know the time. We know the time for the ball to leave your hand, essentially leave the ground and come back to the ground, right? So we're given time. What else do we know? Well, we know acceleration, right? We know acceleration is just minus 10 meters per second. If you're actually playing this game for money or something, you probably want to use a more accurate acceleration. You could look it up on Wikipedia. It's minus 9.81, whatever, meters per second squared. And do we know the change in distance? At first you're saying, well, Sal, I don't know how high this ball went. But we're talking about the change in distance over the entire time, right? So it starts at the ground, essentially at the ground. I'm assuming you're not like 100 feet tall. You're essentially at the ground. So it starts at the ground and it ends at the ground. So really the change in distance, delta D, is 0. It starts at the ground and ends at the ground. This is interesting. This is a vector quantity, right? Because the direction mattered. If I told you how far did the ball travel, well, then you would have to look at its path and say how high did it go and where did it come back. And actually, if you wanted to be really exact, the change in distance would be the height from your hand when the ball left your hand to the ground. So if you're like 6 feet tall or 2 meters tall, the change in distance would actually be minus 2 meters. But we're not going to do that because that would just be too much. But you could do it if there's ever a close call between you and a friend and you're betting for money. So let's see. You're given these things, and we want to figure out. So we want to figure out a couple of things. We want to figure out. Well, the first thing I want to figure out is how fast did I throw the ball? Because that's what's interesting. Because that is that would be a pure test of testosterone. So how fast? So I want to figure out VI. VI equals question mark. Well, which of these formulas can we use? And actually, I'm going to do it first with the formulas, and then I'm going to show you kind of almost an easier way to do it, where it's more intuitive. But I want to show you that these formulas can be used for fun with your friends. So let's see, we know time, we know acceleration, we know the change in distance, so we could just solve for VI, right? So let's do that. So in this situation, change in distance is 0. Let me change colors again just to change colors. So change in distance is 0, right? Change in distance is 0 is equal to VI times time. And let me put the G in for here. So it's minus 10 meters per second squared divided by 2. So it's minus 5 meters per second squared, we could say almost. So it's minus 5t squared, right? All I did is I took minus 10 meters per second squared for A, divided it by 2, and that's how I got the minus 5. If you use 9.81, whatever, this would be 4.905 something something. But anyway, let's get back to the problem. So if we wanted to solve this equation for VI, what could we do? Well, this is pretty interesting because we could factor a t out, and this actually, and what's cool about these physics equations is that everything we do actually has kind of a real reasoning behind it in the real world. So let me actually flip the sides and factor out a t just to make it confusing. So I get t times VI minus 5t is equal to 0, right? All I did is I factored out a t, and I could do this. I didn't have to use a quadratic equation or factor it because there wasn't a constant term here. So I have this expression, and if I were to solve it, assuming that VI is some positive number, I know that there's 2 times where this equation is true, right? Either t equals 0, or this term equals 0. VI minus 5t is equal to 0. Or, since I'm solving for velocity, we know that VI is equal to 5t. Interesting. So, what does this say? There's 2 times. If we knew the velocity, we could solve it the other way. We could say that t is equal to VI divided by 5, right? These are the same things, just solving for a different variable. But that's cool, right? Because there are 2 times when the change in distance is 0. At time equals 0, of course, the change in distance is 0 because I haven't thrown the ball yet. And then at a later time, or my initial velocity divided by 5, it'll also hit the ground again. So those are the 2 times that the change in distance is 0. So that's pretty cool. This isn't just math. Everything we're doing in math has kind of a application in the real world. So we've solved our equation. VI is equal to 5t. So if you and a friend go outside and throw a ball, and it takes literally, and you try to throw it straight up, although we'll learn when we do the two-dimensional projectile motion that it actually doesn't matter really if you have a little bit of an angle on it, because the vertical motion and the horizontal motions are actually independent, or can be viewed as independent for each other. But if you want to figure out, and this velocity you're going to get if you play this game is going to be just the component of your velocity that goes straight up. Okay? I know that might be a little confusing, and hopefully it'll make a little more sense in a couple of videos from now when I teach you vectors. But the velocity, if you were to throw this ball straight up and time it, when it hits the ground, then this velocity would be literally the speed, actually the velocity at which you throw the ball. So what would it be? Let's see. If I threw a ball and it took 2 seconds, if it took 2 seconds to go up and hit the ground, then I could use this formula, and this is actually 5 meters per second squared. 5 meters per second squared. Times t, right? Times t seconds. So if it took 2 seconds, so if t is 2, t is equal to 2, then my initial velocity is equal to 10 meters per second. And you could convert that to miles per hour. We've actually done that in previous videos. If you throw a ball so fast, let's see, if you throw a ball that stays up in the air for, I don't know, for 10 seconds, then you threw it at 50 meters per second, which is extremely, extremely fast. So hopefully I've taught you a little bit about a fun game, and in the next video I'll show you how to figure out how high did the ball go. I'll see you soon.